In 2016, 14% of the world's population still lived without electricity, mostly located in rural areas of developing countries. Access to electricity is a prerequisite for human development. It contributes to a better quality of life, and those who live in areas that are electrified gain improved health services and education, as well as economic opportunities. Productivity increases with businesses substituting manual work by automated processes, and finally leading to a positive virtuous growth cycle. Access to energy also offers great benefits to development through the provision of reliable and efficient lighting, heating, cooking, mechanical power, transport, and telecommunication services. According to the United Nations, sustainable development is not possible without sustainable energy, such that the issue has been prioritized by devoting a standalone goal for sustainable energy, which implies universal access to affordable, reliable, and modern energy. Off-grid and mini-grid systems are summarized under the term distributed energy systems and come as a solution for rural electrification. Let's focus on solar energy and wind power. So what is solar energy? We consume energy in dozens of forms. The sun's energy warms the planet's surface, powering huge transfers of heat and pressure in weather patterns and ocean currents. Solar energy also evaporates water that falls as rain and builds up behind dams, where its motion is used to generate electricity via hydropower. When sunlight strikes a plant, some of the energy is trapped through photosynthesis and is stored in chemical bonds as the plant grows. We use the stored energy as coal, oil, or natural gas. Either way, we're reclaiming the power of sunlight. However, the radiation of the sun can be used to heat or can be directly used to generate electricity. Solar technologies are broadly characterized as either passive or active depending on the way they capture, convert, and distribute sunlight. Passive solar techniques include selecting materials with favorable thermal properties, designing spaces that naturally circulate air, and referencing the position of a building to the sun. Some of the solutions are crops dryer, greenhouse, solar air heater, water distillation, and solar cookers. Active solar techniques use photovoltaic panels, pumps, and fans to convert sunlight into useful outputs. In solar thermal systems, a collector gets the energy of the sun to heat a fluid that can be used to heat at the same time water or air in order to be used as air conditioning system, water for shower, or even to run a steam turbine and generate electricity. In rural areas, however, the most utilized solar energy technology are the photovoltaic panels. Let's have a closer look.
The cells of a photovoltaic panel are made out of a semiconductor, typically silicon. A semiconductor is a material that normally does not conduct electricity, but it can be made more conductive if certain conditions are met. The top layer of the silicon cell is covered with phosphorus, which has an excess electron. Therefore, this layer is called N-type. On the other hand, the bottom layer of the cell is covered with boron, that has an electron deficiency. This absence of an electron is an effective positive charge. Therefore, this layer is called P-type. The N-type and the P-type create a p-n junction that generates an electric field. When photons with a specific wavelength reach the surface of the cell, they knock an electron from its bond, leaving a hole. Due to the electric field, the electrons go to the N-type and the holes go to the P-type. If a load is connected, electric direct current can be delivered. Usually, a controller controls the DC, conducting it to an inverter, which transforms the DC into AC, so usual electronic systems, such as a smartphone, can be powered. If there is a spare energy, the controller can direct part of the current to a battery to store it.
PV systems may be used in different ways. Technological solutions range from very small applications such as solar picosystems used for lighting to replace kerosene lamps to mid-scale solutions like solar home systems. Solar home systems enable the provision of electricity for basic requirements regarding lighting and information for households. This includes radio and television, as well as information and communication technology. Additionally, non-domestic applications are possible, such as powering water pumps, cooling facilities for medical purposes, telecommunications, navigational aids, health clinics, educational facilities, and community centers. PV systems have also been installed in large-scale projects such as hospitals or whole communities.
Off-grid solar energy has been one of the fastest growing industries in the provision of electricity access. In 2016, more than 7 million Pico PV systems were sold worldwide. That represents an increase of 41% compared to 2015. In addition, more than 6 million solar home systems were in operation around the world, benefiting 25 million people.
Wind is a form of solar energy. Winds are caused by the uneven heating of the atmosphere by the sun, the non-uniformity of the Earth's surface, and the rotation of the Earth. Wind flow patterns are modified by the Earth's terrain, bodies of water, and vegetative cover. This wind flow or motion energy, when harvested by modern wind turbines, can be used to generate electricity. Wind turbines convert the kinetic energy in the wind into mechanical power. This mechanical power can be used for specific tasks, such as grinding grain or pumping water, or a generator can convert this mechanical power into electricity to power homes, businesses, and schools. So what are the components of a turbine? Horizontal turbine components include rotor blades, which converts the energy in the wind to rotational shaft energy, a drivetrain, usually including a gearbox and a generator, a tower that supports a rotor and drivetrain, and other equipment such as controls and electrical cables.
Each wind turbine has a wind vane at the top that indicates the wind direction. This allows the turbine to rotate on the tower and face the wind. The blades also rotate on their longitudinal axis. Wind force, that is the kinetic energy contained in moving air currents, spins the blades. These are designed to fully capture this energy. They can be as long as 80 meters each, and they are made of very light and resistant materials for ease of movement. This is why they can produce energy even with very light winds, starting from about 11 km per hour. With very strong winds, above 90 km per hour, the blades are placed in the feathered position, and the turbines stop spinning for safety reasons.
The blades are attached to the wind turbine through the hub, which is coupled to the low-speed shaft. The low-speed shaft is given this name because it spins at the same speed as the blades, between 7 and 12 revolutions per minute. To produce electricity, it is necessary to increase the turning speed of the low-speed shaft. The high-speed shaft, which rotates up to 1500 revolutions per minute, is connected to a generator. The generator converts the kinetic energy into electricity, a source of energy that is easier to transport and use. The electricity produced in the generator as direct current is conducted through the interior of the tower to the base. There, a converter transforms it into alternating current, which is the most commonly used kind, and a transformer raises the voltage for the transport inside the wind farm.
From each turbine, alternating current is sent to the substation through underground cables. There, the voltage is increased again to feed it into the power grid and transport it to the end consumers. Oftentimes, a large number of wind turbines are built close together, which is referred to as a wind park or wind farm. A wind farm functions as a single power plant and sends electricity to a utility grid.
Wind turbines are available in a variety of sizes and therefore power ratings. The largest machine has blades that span more than the length of a football field and produces enough electricity to power 1,400 homes. A small home-sized wind machine has rotors between 2.5 and 7.6 meters in diameter and can supply the power needs of an all-electric home or small business, telecommunications, washing dishes, or water pumping.